Welcome to all. Now we are going to see about the modes in planar waveguide. So, what is a planar guide? It is the simplest form of a optical waveguide. So, it contains a slab of dielectric whose refractive index is N1, and this material is sandwiched between two regions of lower refractive index N2. So, the refractive index within the guide is N1, and what is the optical wavelength in this region? It is reduced to lambda by n1 because that material is different when compared to air. So that material is having a refractive index of n1. What is n1? N1 is a ratio of velocities. This velocities depends upon the material. So when compared to air, the core is made up of a different material. So the wavelength in this region will be reduced to lambda by n1, but the vacuum propagation constant is increased to n1k. So we have scaled the vacuum propagation constant in terms of n1. What is k? K is a propagation vector. So that is, it gives the direction of the propagation and rate of change with distance. K is equal to 2 pi by lambda. It is also called as a free space wave number. See, in this direction, you can find how the light wave is propagating inside a planar waveguide. So this is the propagation of light. This light wave is resolved into two components, that is beta x and beta z. This is z direction along the axis of the core. This is the x direction we have taken. See, this is the x direction, this is z direction. So what is beta x? That is equal to n1k cos theta. Well, then what is beta z? That is equal to n1k sin theta. So the wave is propagating like this. It can be along the x direction. What is the propagation constant, and along the z direction what is the propagation constant? Hmm. See, the wave is propagating like this. So light ray is composed of numerous waves. So this is also one of the wave you take. So as it propagating, see the corresponding intensities. When it is in this position, you will be getting an intensity like this. As it moves, the intensity is gradually increasing. It is maximum at this point, then like this, and so on. So this is a cross-sectional view. So at the axis, the intensity is maximum. As it moves away from the core axis, it is getting reduced. So the propagation constant in the z direction is equal to beta z is equal to n1k cos theta, and in x direction is equal to beta x is equal to n1k sin theta. So the component of the plane wave in x direction is reflected at the interface between the higher and lower refractive index. See, it is reflected. That this is the component of the wave, this is the interface, is reflected. This area, this is the core, this material is having a high refractive index, this is the cladding region, it is having a lower refractive index. It is reflected at the interface. So it is reflected the interface in the higher and lower refractive index media. So when the total phase change after two successive reflections in the upper and lower interface between points P and Q. So between the points between this one as well as between this successive reflections, this is one reflection, this is one reflection, this is the point between the two successive reflections we say. This is one reflection and this is between the points P and Q. Hmm. So when a total phase change after two successive reflections at the upper and lower interface, if it is equal to 2 m pi radians, means constructive interference occurs. That is, the phase difference should be equal to 2 m pi radians, then constructive interference occurs and a standing wave is obtained. Mm. So now, what about the electric field? It is maximum at the center of the guide. It is gradually decreasing towards zero at the boundary between the guide and cladding. And but it also penetrates not only inside the core, inside the cladding also some portion of the field is present. It is the field is penetrating inside the cladding also. This stable field distribution in the x direction with only a periodic z dependence is known as mode. The stable, this is the field distribution. As it propagates along the z direction, it is changing. It is changing. This stable field distribution and dependence on z. This is called as the mode we say. A specific mode is obtained only when the angle between the propagation vectors or the rays and the interface have a particular value. So this is a field propagation when m is equal to 1. This is for m is equal to 2. This is for m is equal to 3. So this m depends upon the angle we say. Depends upon the angle between the propagation vectors and the interface. So for different angles, you'll be having different m values. Thank you.